Hi, my name is Willy, and I'm doing my physics project about goalkeeping, and I'm going to talk about the physics behind it. So in goalkeeping, there are two main quantities. It's momentum and impulse. Momentum is described as an object's tendency to remain in motion. The formula for momentum is P equals mv. P is described as momentum, and m is the mass, and v is the velocity. In this case, with the soccer ball, the mass doesn't really matter in this case because, well, it does matter, but hardly, because it's very light. It's less than 1 pound. Most of the momentum comes from the velocity or the force you put from your leg to boot the ball. So if you haven't played soccer like ever, being a goalkeeper isn't that easy. It's not just like stopping shots, but nowadays you're also like an 11th player because there's 10 players, well, 11 players total playing, including the keeper. But now you're like included in outfield, which means that like you actually like pass the ball and you like make set pieces for your team to score. So first we're going to talk about passing, but for keepers it's called distribution. So in terms of physics, let's say I want to boot the ball like all the way to a teammate on the other side of the field. So technically, I would try to shoot the ball from under, because if I shoot under, the angle of the ball will go higher. But in terms of, let's say there's a player right there, that blue ball right there, and let's say I want to pass to that, I'm not going to hit it from under, or it's going to like boot it out into the sky, right? Usually I want to hit the middle of the ball, so I don't gain the momentum up high into the air, and instead just like give it a force and pass it to the other ball. To put that in perspective, because when I hit the ball low at the bottom part of the ball, the reason why it boots up is because I have a force that's going this way. What do you call that? Northeast, the direction northeast. And because I'm hitting it northeast, the ball is going to follow my foot, collide, and go northeast in that perspective from where you're watching. In this case, if I hit it from the middle of the ball, there's going to be a force that goes just east. It's not going to go up in the air because I don't have a force that's actually bringing it up. I'm not like giving it momentum to go up. So, for example, if I hit the ball from the bottom, I expect it to boot up into the sky like this. Momentum also applies with two kinds of collisions. One is elastic and one is inelastic. So elastic collisions is when two objects collide. In this case, it could be my leg, well, my foot, and the ball. And when I hit it, they don't stick together. Like, let's say, like a pool, for example, like you're playing billiards. Let's say you hit the ball, a white ball, and it hits another ball. They're not going to stick together after they collide. Same case for this, because let's say I pass the ball to somebody, I pass it, the ball is not going to stick to my foot. Instead, the ball is going to go away because I use force and collide with it. Inelastic collisions, for example, this doesn't pertain to soccer at all because the ball is never going to stick to my foot. But inelastic collisions is when I hit the ball, but it sticks to my foot as I kick it up. That's never going to happen. That just doesn't make sense. So in this case, for goalkeeping, the only collisions that occur are elastic collisions, when they leave my foot and they take the momentum gained from my own leg, my own force that I apply to boot it where I want to go. So after momentum, the second quantity in goalkeeping is called impulse. So impulse is basically the amount of force I apply on this ball and the duration of time I apply it on. So let's say you're a keeper, you just make like a wonder save, right? Like you make a wonder save. You get up, and let's say you want to make a counterattack. If you don't know what that means, it basically means like your opposing team attacked you, and now you're trying to attack the other team to try to score a goal for your team. So let's say I see a player that's like all the way over there, like all the way close to the second goal. So in that case, I would want to boot the ball as far as I can and as accurate to my teammate. So this is where impulse can come in play. There's two kinds of volleys that keepers use. There's a normal volley like this. You drop it and you kick it from straight up. And another way is a side volley, which is more popular. It's when you go from the side and you hit it like that, like you hit it from your side. That's why it's called a side volley. So in this case of impulse, I would want to use the straight volley because when I hit the ball, I preferably want to hit it in a way where the ball ends up 45 degrees from my collision with my foot. Because for 45 degrees, it goes the furthest, it doesn't go too high, and it actually travels like the farthest it can. So when I kick the ball regularly, the regular volley, when I hit the ball, I follow through with my foot and then I kick it up. So with the side volley, I don't, because it's impossible for me to follow through with the ball after it collides, booting it that way. An example of a regular volley, when I fall through the ball, giving it a more duration of time, where I put force on the ball, which needs more impulse, is like this. So I drop the ball and I boot it. See how far that goes? It took me a few tries because I personally are not good at side volleys, so I prefer the straight volleys, but here's an example of one right here. The reason why I didn't go as far is because it had less impulse, because I couldn't follow through the ball with my foot compared to the straight volley that went all the way over there. Now I'm going to talk about how physics portrays in the main role of goalkeeping, shot stopping. Ready? Yeah.
There we go.
So whenever an opposing team tries to shoot, I have many options to try stopping the shot. For example, the save you just saw, I pushed it above the bar. Another way, I can save the shot and put it along the post, outside the post. Another way I can do is honestly just catch it. It really depends on what kind of shot it is and whether it's easy or not. So in this case, there are many strategies to stopping shots. So in the example you saw, usually a soccer field is built, well, one half of a soccer field is built with two boxes. There's a 6-yard box and there's an 18-yard box. Where I was standing, I was near 3 yards from the goal, because the closer you are to the striker or the person that shoots, the harder it is for them to score. For example, if I'm right here, if he shot that, I'm not saving that, because this goal was way too big. It's 24 feet wide and 8 feet tall. I can't even touch the post. It's like I was like on my tippy toes. Okay, it's really big. So usually I want to get as close as possible, and not too close to stop the shot. The reason why I don't want to go too close is because they can chip the ball or loop over me. The save you just saw, I was standing right here, about 3-ish yards from my goal, and Chris was about like right there, if not a little closer. So usually in an actual like scenario, if it's just us two like this, and I'm the only one between him and the goal, I will try to come up as fast as I can and block the angle, because the closer I am to him, the bigger I look, and the more I cover the goal behind me. All right, let's say that Chris is shooting off of right outside the 18-yard box. So usually I would stay about halfway from the 6-yard line box, which is 3 yards. So I'd be standing about right here. And if he's shooting from the middle, I try my best to like make the position where I'm not too much to the left or too much to the right. In this case, this is the middle of the goal, and he's shooting from the middle, so my position is good. So when he shoots, I need to think about how close I am or how far I am from the goal. Because remember, the closer I am, the more angle I like close out, and the higher chance I get to save it. So in this case, when I save the ball over this bar like this, there's always going to be a specific kind of angle I have to hit the ball in to get it over the bar. For example, when I did that upper hand save, when I jumped to my left, the reason why I was able to put it above the bar is because I hit it with my fingers up that way, because of the angle I put my fingers in to bring the ball over. For example, if I hit it with my palm, it's just gonna deflect back. It's not gonna go over the bar. See, like I have to use power because I can't get power from my foot. So Chris, throw it to me real quick. So if I hit it like this, it's not gonna go over the bar. Instead, it's just gonna deflect off my hand and go straight for a rebound for Chris to shoot again and score. So if I want to not let her, so my number one goal is to get the ball out of bounds in this case. That way I don't have to worry about no rebound or like a higher chance of me getting scored on. So in this case, when I'm stopping the ball, I want to hit it I want to put my hand in a specific angle to put the ball over. For example, if I put my hand straight like this, it's gonna deflect off and it's not gonna go over the bar. If I put my hand at an angle like this, the ball is gonna go up because it's gonna shoot like this. It's really hard to explain, but basically, if I hit it like this, it's not gonna go over. But if I hit it like this, it is gonna go over. I don't even know how to explain that. in terms of goalkeeping and physics correlating, that's all there is to it. So thank you for watching my video, and please give me 100.